Hello friends, I hope you are ready to have more fun. In this lesson, we will be preparing for exam questions on bearing. For our first example, a ship sails Q kilometers due east to a point E and continues Q kilometers due north to F. Find the bearing of F from the starting point. Now, let's begin by making a sketch from what we have in the question. So, if this is our starting point, then due east to E will give us this new location, and the distance is Q kilometers. Again, due north to point F gives us this point, and the distance is also Q kilometers. Now the question says we should find the bearing of F from the starting point. That means if we draw a line from the starting point to point F, this angle is what we are looking for. Now the first thing you will notice here is that we have a right-angled triangle. Again, you will notice that this is an isosceles right-angled triangle because two of its sides are equal. What this means is that the base angles are also equal. So let's call them X. And then the bearing that we are looking for, we'll call it Y. Let's begin by finding the value of X. Now recall that the sum of angles in a triangle is 180 degrees. So what this means is that X plus the right angle is equal to 180. Collecting like terms, we have X plus X equal to 180 minus 90, which gives us 2x equal to 90. And to get the value of x, we divide both sides by 2, which gives us x equal to 45 degrees. Now, to find the bearing of F from the starting point, all we have to do now is to subtract x from 90 degrees. So the bearing is 90 minus x, which is 90 minus 45, and this gives us 45. So the bearing is 0.45 degrees. Let's take another example. Debbie starts from a point A and walks 125 meters on a bearing of 85 degrees. How far north is she from her starting point? Again, we make a sketch first. So, if this is point A, where she started from, we are told that she walks a distance of 125 meters on a bearing of 85 degrees. So, we label that angle as 85 degrees. The question is asking us how far north she is from her starting point. So if we draw a horizontal line to her current position and a vertical line from her starting point, what we want to know is the length of the line which is marked as x. Now we are going to use our SOHCAHTOA. In this right-angled triangle, we are required to find the adjacent, and we have the hypotenuse. So we are going to use cosine. This gives us cos 85 equal to x over 125. Now collecting like terms and making x the subject of the formula, x is equal to 125 times cos 85. Now from our tables, we'll get the value of cos 85 to be 0.0872. And when we multiply those values, x is equal to 10.9 meters. This means that Debbie is 10.9 meters north of her starting point. Let's take one last example and then we end the lesson. A ship sails from a port O on a bearing of 300 degrees to a point T. If T is 10 kilometers west of O, find OT. Again, we make a sketch. So, if this is the starting point, which is O, now 300 degrees will give us a value in this direction. And here we have point T. Now recall the bearing here is 300 degrees. All right. Now, we are told that T is 10 kilometers west of O. This means that if we draw a horizontal line from T and a vertical line from O, the length of that horizontal line is 10 kilometers. And then we are to find line OT. Let's call it X. Now at the point where we have 300 degrees, within the triangle we are going to have 60 degrees because the angle at a point is 360 degrees. So when we remove 300 from 360, we have 60 degrees. Now in this right-angled triangle, we have the opposite of 60 degrees and we are to find the hypotenuse. So we use our sine ratio and we have that sine 60 is equal to 10 over x. Making x the subject of the formula, x equals 10 over sine 60. Now the value of sine 60 is 0.8660. So when we divide 10 by 0.8660, we have 11.5473, which is approximately equal to 11.5 kilometers. This means that the length of line OT is approximately 11.5 kilometers. Now, I know that you are very ready to solve more test questions on bearing, so keep practicing.